We're now going to do a small sample hypothesis test where you have to calculate the mean and standard deviation before you perform the test. And so for this one, I'm going to want you to pause the video and try it yourself first, and then when you're done you can restart the video and see how you do. And before you do that, notice this is greater than. I actually had the wrong thing there. So you're testing to see if the mean wait time is greater than 2 minutes. So go ahead and pause the video and give this a try, and then you can turn it back on and we'll work on it together. Okay, so let's see how you did. So in this case, we have Mac Dolly's Fast Food Supermart, and they claim that the average wait time is 2 minutes. And to test the claims, we take a sample of customers and get the wait time. And we want to see if there's enough evidence that alpha equals 0.05, if there's enough evidence to conclude that the true mean wait time is actually greater than what they claimed. Okay? So we need to start by calculating the sums and then the mean and standard deviation. Okay, I'm going to use my calculator to get these sums here. So mode 2, so 1.7 m plus 2.4 m plus 2.9 m plus 1.9 m plus 2.1 m plus 2.3 m plus 2.5 m plus 1.6 m plus 2.4 m plus 1.8 m plus. So we got 10 values in there. So now to get the sum of x, I'm going to hit shift 1, 2, and I get 21.6 for my sum of x. Okay, shift 1, 1. Now the sum of x squared, I got to hit equals, and I get 48.18. And then my n is 10. Okay, so my mean is going to be the 21.6 divided by 10. And that's going to equal 2.16. And that's perfect because if I have to round, I want to round to one more decimal place than the data in the data set. And these are all to one decimal place. So I'm going to be rounding to 2 decimal places. Okay, so S, I'm going to take the sum of x squared minus the sum of x, that quantity squared divided by 10, all over 10 minus 1, and then I'm going to take the square root of that. So let's see what I get here. So 48.18 minus 21.6 squared divided by 10, hit equals, divide this by 9, hit equals, take the square root, hit equals, and I get 0.41. I'm going to round to 2 decimal places. 0.41. Okay, and so there's my mean and standard deviation. So now, what is the hypothesized mean in this case? Okay, it's going to be their claim of 2 minutes. Okay, so the null hypothesis says there is no difference. The true mean is equal to 2 minutes. And I want to test to see if the true mean is actually greater than 2 minutes. Okay, so we'll set up my critical region. So my alpha is 0.05. My degree of freedom is 10 minus 1, which is 9. This is a right-tailed test. And so I'm going to go to my table. I'm going to go to alpha equals 0.05. And I'm going to go to 9 degrees of freedom. Looks like it's 1.833. Just like before, isn't it? I didn't realize that. Okay. So, this would be the reject H0 over here. Okay, so it has to be bigger than 1.833. Okay, so my T statistic is going to be 2.16 minus the hypothesized mean, which is 2, divided by 4.1 over the square root of 10. So 2.16 minus 2, divide that by 0.41 over square root of 10. And it looks like I get approximately 1.23, and that does not lie in the rejection region. Okay, so 4, I'm going to fail to reject H0. And so there is not enough evidence to conclude true mean wait time is greater than 2 minutes. Okay, so if you think about the type 1, type 2 errors, I'm failing to reject H0, which means I run the risk of committing the type 2 error, right, which would be accepting H0 when it's false, so it's not concluding that it's greater when it really is. That would be the type 2 error. You know, but my test statistic is really pretty small. Okay, I would probably reject it at all the significance levels pretty much. Okay, and so this is probably a good decision. We really don't have very much evidence at all. So if it is a little bit greater than, it's probably just very slightly greater than. Okay, so certainly at the 0.05 significance level, the difference is not statistically significant. Okay, and so that is the hypothesis testing. Here you're doing it from beginning to end. You're calculating the mean and standard deviation, performing the tests, interpreting the results, and even that little bit of analysis at the end where you realize which of the two errors you could be making and how likely that is. And in this case, there's not very much evidence at all, and so if there is a difference, it's probably very small. Okay, so that is hypothesis testing. So good luck on the homework over that, and remember to be on the lookout for the sample size, because they won't always come in problems like this where you have to calculate the mean and standard deviation. Okay, you could have problems that look like a normal one, and the only difference is the sample size is less than 30, and in those cases you need to use critical t values and not critical z values.